Okay, question number 20. Okay, is a cell is connected in series with a resistor. A cell is connected in series with a resistor. I always try to write down the equation or maybe with the circuit, and supplies a current of 4 ampere, for 500 seconds. 500 seconds. Okay, and during this time 1.5 kilojoules of energy is dissipated in the cell. Why should a cell dissipate energy? Because it has some internal resistance, right? Some internal resistance over here. Okay, and is dissipated in the cell, and 2.5. Okay, what is this? 1.5 kilojoules. 1.5 kilojoules, and 2.5 kilojoules of energy is dissipated in the resistor. Here it is 2.5 kilojoules. 2.5 kilojoules. Let me complete the circuit. Now the problem, whatever is given here, is written in the form of a circuit. What is the EMF of the cell? What is the EMF of the cell? Okay, see the EMF of the cell. First, let us understand this. Why do these resistors dissipate energy? Who gives the energy to lose energy? Okay, that's a question we need to ask. Who gives energy for these resistors to lose energy? The EMF of the cell provides the energy. So therefore, the energy loss here plus energy loss here should be equal to energy given by the cell. That's what we know. Okay, so therefore now what we do is, let us consider what is the energy given here. Energy loss here is nothing but voltage dropped here multiplied by the current passing through it multiplied by the time taken. This will be equal to V into R, VR. That means the voltage across the cell R. Sorry, this will be the, not voltage, this is the energy lost at cell R. Okay, now what is ER here? 1.5 kilojoules. 1.5 kilojoules, I'll write this as 1500 is equal to, this is voltage across this, I'll write this as VR, multiplied, what is the current? Series circuit, same current, 4 ampere, multiplied by time taken is 500. When I do this, 500 ones are, 500 threes are, so therefore VR should be 3 by 4, which should now be equal to 0.75 volt. So here it is 0.75 volt. Okay, next, in a similar way, let us do it for this also. Let us do it for this also here. So let the voltage drop across this one be equal to V capital R. V capital R multiplied by current passing through it is 4 ampere multiplied by time taken 500. Why did I take V into I into T? The reason is nothing but V into I into T is nothing but voltage into current into time. Voltage into current is power. Power into time is energy. Okay. So therefore, this should be equal to, what is the energy lost? 2.5 kilojoules, which is 2500. 0000, 5 ones are, 5 fives are. So therefore, VR should be equal to 5 by 4, which should be equal to 1.25 volt. Now this VR and this small VR, right? This small VR plus VR, the total sum of these drops according to KVL is nothing but the total EMF, which should be equal to EMF. What should this be? This should be 0.75. This should be 1.25. Totally 2 volts. This 2 volts is the total EMF of the cell. So answer is D over here.